So I would like to go over a problem that you've been asked to solve when you were working on your activity learn assignment. They ask us to calculate electric field a distance of 2 millimeters away from a negative 4-coulomb charge. Then they ask us to calculate the force on negative 2 coulombs charge placed at this point. So first we're going to start with the electric field. I write it down here, formula for electric field. When K is our constants, we have right here R or D will be our distance, which is 2 millimeters. Usually those kind of problems we start with writing down all these quantities that we have given. So in this case we will have our R, which is the distance, is 2 millimeters. So that's what it is. Other things that we have in here, it's a charge of negative 4 coulombs and charge of negative 2 coulombs. So what we're gonna write this, we're gonna write the first one as big Q, uppercase Q, and then the second one right here, we're gonna write at our regular Q, lowercase q. All right. So first, we're gonna use this formula for electric field because that's what we've been asked for. First, we're gonna plug this for the K. We're gonna plug this for our Q, and for our distance, we're gonna put 2 millimeters. Since we have to change millimeters to meters, this is 0.002 meter. That's easy to change. If you need help with changing, you can look it up online. There are some tools that you actually can use and change them from milliliters to meters if you have issues with that. So what we're gonna do here, we're just gonna start plugging in. So then we have our K, it's right here. This is this. So we're gonna write 9 times 10 to the 9th. I will skip the units for now, so it's easier for us to calculate this. Then we have Q, and our Q is right here, okay? So we're gonna multiply by negative 4 coulombs. And then we have to divide the whole things by our distance. So our distance is right here, and we're going to be plugging here, right here for a distance. We have the distance to the second power, so we're going to plug in here 0, 0, here to the second power, and that's the basics. So that's what you would be doing. I can actually mark it up for you so you can see what it is, what part, so it will be easier for you. Here we go. That's what it is. So now I actually saw during the assignment that we had, I think I have 8 submissions, and 8 submissions have 8 different results of these calculations. So I want to show you the very quick way how to do it. If we have multiplication right here, it's very easy to multiply just those two numbers, leave the tenths out. So in this case, we have 9 times minus 4 will be negative 36 times 10 to the 9th power. Then we have to take this right here to the second power, or distance to the second power, and I can show you a very easy way how to do it. We're gonna leave it right now as it is, so I can move on the other side, other page, and show you. Lots of you, and not only you, everybody actually, have trouble sometimes with this when we have the zeros and those places, decimal places. We either add a space or we take the 0 away. So here, when you look at this number, right here, and you have to put it to the second power. First, what you're gonna do, you're gonna figure out what number you are going to have in here. So what we're gonna have in here when we're gonna take a 2 to the second power, it will be 4. So we can write in here 4, and then we wanna write this in the scientific notation. So we know we're gonna have it times 10 to some kind of power right here. So what we're gonna do now, we're just gonna count the spaces, since we're gonna have pretty much multiplying this by this right here. We're just gonna take how many spaces we have to move to get to 2 in here. So we have 1, 2, 3 spaces. If we move 3 spaces, the decimal point 3 spaces to the right, we're gonna end up with just 2.0, right? The same right here, 1, 2, 3 spaces. So together to the right, we need to move 3 spaces. Moving to the right tells us that we have a negative, right? And then, negative and 3 spaces and 3 spaces will give us total 6 spaces, okay? So this is pretty much 4 times 10 to the negative 6. So we can write in here, okay? And then what we're gonna do, we're just gonna do the math right here, since we have a multiplication everywhere and the division. Negative 36 divided by 4 is 9, negative 9. Let me switch for that, negative 9. And then we need to see what's gonna happen in here with this tens. So this is those exponents. What happened to the exponents 9 and negative 6 when we divide them? This is simple math and quick review. When we divide them, we're pretty much subtracting them. So in order to have this times 10 to some power right here, we're gonna subtract them, so the exponents. So we're gonna use 9 minus 6, right? Because subtracting them is actually adding us another minus. 2 minuses will give us positive. We have 15 right here. So this will be electric field will be negative 9 times 10 to the 15th power, okay? And that is our oral E. The next things what we're gonna do, we are going to calculate the force that is due to the electric field on the charge of negative 2 coulombs. Okay, so what we're gonna do, we have the equation right here for the force, and it's very simple equation. We just need electric field that we just calculated times the charge, which is negative 2. Very simple math. Negative 2, I forgot this is negative 9. Negative 9. So we have negative 2 times negative 9 times 10 to the 15th power, and negative 9 times negative 2 is 18, since the 2 minuses go away, times 10 to 15. Okay, and that's our force. And that will be it. I'll look through it, and I would like you to solve the problem that I attached in your assignment and make the submission through Schoology, and that will be it for today. Thank you.